explore basic properties of logarithmic functions. Let's start with an exponential function, which is a function defined by the formula a to the x. We saw that this function is 1 to 1. We saw that every 1 to 1 function has an inverse. So we can talk about f inverse. Let's give a name to this function. It's called the logarithm to the base a. The a here is the same a that is in the exponential function we started with. So we'll write f inverse of x as log sub a of x. Let's recall the fundamental relationship between a function and its inverse. Again, this says that if y is the output of x for the logarithm, then x is the output of y for the exponential. And vice versa. If we start over here with x being the output of y for the exponential, then y is the output of x for the logarithm. We interchange the inputs and outputs. So if we were to ask the question, a to what power equals x, we see that this is the number log base a of x. Here x is positive, right? The output of the exponential function is always positive. So for positive x and any a, again, a is always like this. We want to find the number such that when a is raised to that number, we get x. And that's exactly what the log base a of x does. So two important logarithms, log base 10, and often we just simply write this as log of x. And also when a is e. We often write log base e of x as ln of x. What about the graphs? Let's look at the relationship between the graphs. Let's start over here on the left. This is the graph of a to the x, where a is greater than 1. And how does this relate to the graph of log base a of x? Well, since these two functions are inverses of each other, we automatically know 3 points on the graph of the logarithm. Since 0, 1 is a point on the exponential, 1, 0 will be a point on the graph of the logarithm, as will be a, 1, which will be over there, and 1 over a, minus 1. So in general, the two graphs will be symmetric about the line y equals x. How about over here? This is when a is between 0 and 1. What does the graph of a log base a of x look like over here? Well, we have the same 3 points. We have 1, 0, which is right here. We have a, 1, which now is up here, since a is between 0 and 1. And we have 1 over a, minus 1, which will now be over here. Again, the graphs are symmetric about the line y equals x. So in general, the graph of log base a of x here will look like this.